Hey guys, this is A2 and we're just talking, we're just going to chat about graphs of functions and their derivatives. Okay, so let's say this is a graph of some polynomial function, a cubic function, and we're just curious about like what's the rate of change, what's happening with the rate of change at each interval in the graph. So we should be able to kind of like talk about intervals in our function that have positive, negative, and zero rates of change. So if I was to look at this, basically you separate them by maximums. So we have like what's called maybe a local maximum here and a local minimum here. They're just like, humps in the curve. So this is how I would split my graph up. So I can see here that if I were to draw tangent lines to every point on this, I can see that all of the slopes of those tangent lines in this section of my graph would be positive. Now when I get to a maximum value, I can tell that the tangent line to that part would be 0. So I would have 0 as my rate of change. And then I would be heading down to negative values. Oops. And at some point, my tangent lines are going to go actually below the curve. So there's something else weird going on in here that we're going to talk about later. So in this section, I would say all of my rates of change are negative. And then here we go at a minimum point, I've got another 0 rate of change. And then all my tangent lines to my curve are back to positive. So you can see how my rate of change of my function goes from positive to 0 to negative to 0 to positive. So you should be able to tell that from any function. You should be able to describe the intervals. So if you had, if you had a parabola, you should be able to tell that, that's going to be your kind of dividing line. So this section right here is going to be like 0. And then prior to it, it's going to have a positive rate of change. And then after that, it's going to have a negative rate of change. So you should be able to describe all the sections of a function and what their rates of change will be. We should also, from the last couple of videos, we should also be able to make the connection that for polynomial functions, it seems that their derivatives are always 1 degree less than the original function. So if we had a function y equals x squared, like we had in the first video in this section, we found out that the derivative of y equals x squared, dy by dx, is actually 2x. So we went from a second degree function to a first degree function. So we could predict things like if we had, a function that was like x to the power of 39, like a 39th degree function, we could predict that probably the derivative of that would end up being a 38th degree function. So a derivative always seems to be 1 less. Your derivative of x to the power of 4, if we found the derivative of that, is actually going to end up being 4x to the power of 3. So we had a quartic function that ends up being a cubic function. So just making those connections. Okay, awesome. I think that's probably it.